Welcome to our review on energy and power. So the first thing we need to know is what we're actually talking about when we say the word power. And quite simply, that is the energy transferred per second. And the units that power is measured in is watts, which is given the symbol of a capital W. Now what we actually find is that the more powerful something is, the faster it will carry out its job. So if we're looking at a motor, the more powerful the motor is, the faster it's going to move the load. Now one thing that we do need to bear in mind is that if we're referring to 1 watt, that means it's 1 joule of energy being transferred in 1 second, but sometimes what they use on the actual questions are some different versions of watts. So that little K in front of the W at the bottom, that tells us it's a kilowatt, and 1 kilowatt is the same as 1,000 watts. So make sure you remember that so you can convert into the standard units of just watts. Once more, we've got another equation that we need to learn here. So power is the energy transferred divided by the time taken. So we can shorten that down to P equals E divided by T, and there's a triangle to help you out as well. To give you an example of the kind of question that you could be asked to do with power, there's one example here. Calculate the power of a heater which transfers 7.2 megajoules to a room when it's left on for an hour. As always with our calculation questions, step 1 is circle, underline or highlight the important bits of information. Now in this example I very kindly converted the megajoules and the hour into our standard units of joules and seconds. But do check the units because that will tell you whether you need to convert or not. Stage 2, as always, is to write down the calculation we are going to use. So power is the energy transferred divided by the time taken. We can then substitute in our standard unit values from our question. So 7,200,000 divided by 3,600. Put that into our calculator and we get the answer of 2,000 watts. What we actually find is that if you look at any electrical device, then they have a power rating on them. Now that power rating is going to tell you how much energy it's going to transfer every second that you use it. So in reality, what we can do is use those power ratings to identify appliances that are going to be cheaper to run. Because the lower the power rating, the less energy it's going to use each second, so the less energy you're going to pay for, meaning it will be cheaper to run it for a longer period of time. One of the best examples are the good old different types of light bulb you can have, and as you can see in that little table on the right there, that the LED is the best light bulb you can have in terms of how cheap it is to run, because it only uses 4 watts of power. Whereas if you compare that to a halogen bulb, for example, that uses 18 watts. So you've got a very clear difference between them, meaning the LED is going to be a cheaper bulb to use, as in the energy it's actually taking in each second. Hopefully at the end of this video you can recall how we calculate power, you can define what power is, and you can use the information from those questions to identify which appliance would be the best one to use in a given scenario.